That was really loud. Welcome to Homework Help 3.9. Well, part 1 of 3.9. I'm going to do it on here. So, the first 9, you are classifying numbers. It says, classify each of the numbers represented below according to the sets to which they belong. If a number fits in more than one set, then list all that apply. So this is what we were doing on the Jamboard. All right, so let's see. We did a lot similar to these on our Jamboard this morning. Okay. You have to think a little bit more critically, all right? So 9 divided by 3, or sorry, 9 over 3. That's really just 9 divided by 3, which is 3. So then you would classify 3. 3 is a whole number, 3 is an integer, 3 is rational, and 3 is real. Okay, so you would put, you can either write it out or you can put the little symbols. So it would be W, the Z thing, the Q thing, and the R. What else? Okay, this one, number 7. The square root of 4 over 9. So before you go, oh my, that's irrational, work through it a little bit. Okay, if you have the square root of 4 over 9, so think back to our radical rules. What this means is you have to take the square root of the numerator and the denominator. So take the square root of 2, sorry. So take the square root of 4, you get 2. The square root of 9, you get 3. So you get 2/3. So now you're classifying 2/3. Okay, so 2/3, it is not a whole number. It is not an integer, but it is rational and it is real. Yeah. I'm gonna let you go on those. Just because we did a lot of those on the Jamboard. Okay, well, I guess some of you weren't there. All right, the square root of 75. If you want to, you can break it down to make sure you're right. So let's factor it. So 75, that's, I don't know, 5. Oh, you can't even really do it because that's 5 times 13. No, it's not. It's 5 times 15. Yes. 5 times 15. Okay, 5 is prime. So let's break down 15 into, oh, go over here, 3 and 5. Okay, now those are prime. So if you were to rewrite it, let me get a little pencil out. So if you were to write it, the square root of 75, you would rewrite it with the prime factors. If I can write in there. Nice. Oh, nice. Nope, maybe. 3. No, I can't write in there. Okay, back to the pencil. So you would write your prime factors in there. So it would be 3 times 5. Oh man, that got away from me. Woo! Times 5. Oh yeah. Wow. So you're looking for groups of 2. So you have 2 5s. So you can pull out a 5. So then this is really 5 square root of 3, which is still irrational. Because the square root of 3 is irrational. That means it's a decimal that goes on forever and it never repeats. So 5 would be irrational and real. Remember, every number is either real or complex. And the only ones that are complex, well, I don't want to tell you. Never mind. Okay. Now you can do the rest by yourself. 10 through 15. It's more practice simplifying radicals, and then you just have to combine like terms. So, I don't know. Let's look at All right, we'll do number 13. So your first step is to simplify all of these radicals. So find the prime factors. So 8. Some of these, if you have them memorized, then you don't have to do the factor trees. Oh, 2. 2 is prime, 4 is not. 2 and 2. So 8 is 2, 2, 2. The square root of 2 times 2 times, times 2. Okay. 2 times 2 times 2. So you're looking for groups of 2. So I have 1, 2, so I can pull out a 2. So 8 is now 2 square root of 2. 2. Square root 2. Okay. 2 square root 2. And then you would break down. So it's going to be a negative sign, so it's minus. And then break down 18 into its prime factors. Go ahead and do that. You can either start with 9 and 2 or 6 and 3. All right, so 18 is, I'm going to do 9 and 2. And then, so it's going to be, hopefully this is what you got, 3 square root 2. So you have 2 square root 2 minus 3 square root 2, and then 32. If you break it down, go ahead and break it down, factor it. You can start with 16 and 2, 8 and 4, either one. Okay. Change the color. Let's make it blue. No. Let's see if that worked. Aha, 32. All right, we'll do 8 and 4. No, we'll do 2 and 16. 2, or I'll do it. You can do whatever you want. 2 and 16. We'll get the same thing. So 2 is prime, 16 is not. 16 is either 4 times 4 or 2 times 8. I'm going to do 4 times 4. Neither of those are prime, so we have to keep going. 4 is 2 times 2, and this 4 is 2 times 2. All right, so 32 is 2, 2, 2, 2, 2, 5 2s. So that means that you're going to have, a little bit higher, plus, and then you can even look at it here. Here's a group of 2, so I can pull out a 2. Here's a group of 2, so I can pull out a 2, and so I'm left with the 1, 2 inside. So that's 2 times 2, which is 4, times the square root of 2. Oh, okay. Not getting better at that. So now you can combine all of these together. So I don't know, 2 square root of 2 minus 3 square root of 2. That's negative square root of 2. So you're just adding all these together. You can combine all these together. So let's do 2 and 4 is 6, minus 3 is 3 square root 2. So that would be your answer. Three square root 2. That would be your answer for 13. Okay, so 12 is similar, break them down, and then combine them, combine the like terms. So they have to have, in order to add them together, they have to have the same root. So like if you had Doesn't matter. We'll do the square root of 5. Ha. Plus, actually we'll do plus, oop, I lost it, plus 2 times the square root of 3. Okay. You cannot add these together unless you change them into a decimal, which we are not doing. You could change them into a decimal. You could change the square root of 5 into whatever that decimal is. Actually, here, let me just do it. Oh no, we're good. Square root of 5. Why don't I just bring a calculator with me? It would make so much sense. Square root of 5. Okay. So I'm not going to write it all out because it goes on forever. So 2.2360679 ... Okay, etc. That's the square root of 5. And then square root of 3 is 1 point something. 1 point. It's the square root of 3 is 1.73205. Okay, but then we have to multiply that by 2. Yeah. So you get plus 3.461 whatever. So if you add those together, plus all right, you get like 5.70016. Okay, it goes on forever. Okay, so you can, if you change them into decimal form, you can add them together and get this never-ending decimal. But we aren't doing that. We're leaving them in radicals. So you cannot combine them together. These are all the square root of 2, so you can add them all together. But these are different, so you cannot. All right. Let's look at, oh, number 15 is a good example of that. Okay, so I have 7 square root 7 plus 5 square root 3 minus 3 square root 7 plus square root 3. So combine your like radicals, I guess. Yeah, combine your like radicals. So I have 7 square root of 7. Do I have another square root of 7? Yes, I have negative 3 square root 7. So I'm going to go 7 square root 7 minus 3. 7 minus 3 is 4. Square root of 7, hold on. Okay, that's 4 square root 7. But then I still have to deal with my other terms that I have. I still have 5 times the square root of 3 and the square root of 3. I hope none of your parents are watching this with all the stickers on my face. Anyways, so then you can combine those together. So I have 5 square root of 3 plus square root of 3 plus 6 square root of 3. And then that's your final answer. You cannot, well, if you change these to decimals, you can combine them, but we're not doing that. We're leaving them with their radical form. Okay. Most of these we did examples close to these in class. Oh, period 5, we didn't do an example like this. I don't want to do this one, but if you had the square root of negative, no, yeah, it was period 5. The square root of negative 7 times the square root of negative 7. Okay, so you have the square, like this one's square root of -2 times square root of -2. If you have the square root of -7 times the square root of -7, another way to write that is the square root of -7 in parentheses squared. Wow, that was kind of bad. But another way to write that is the square root of -7 squared. Well, the radical and the square root and the squared cancel out. So you would just be left with -7. So you don't even need to use I for that one. Okay. Number 20 and number 19, I think, are going to prove to be the most difficult. 19 I'll do, and 20 I'll do one similar to it. Oh, hold on one second. I need to pause you for just a hot second. Hold on. Okay, I'm back. Oh, there it is. So, for number 19, what it requires, well, yeah, is that we know that I squared is equal to -1, okay? I'm trying to think, this, I kind of regret doing this on my screen now. Okay, I'm going to switch over to a Word document. Okay, so we know that I squared equals -1, right? We did that in class. Okay, so then you have to figure out what I think the easiest way to do this problem is to then figure out what is I cubed and what is I to the 4th power, and then you're going to multiply all of those together. All right, so let's, I really don't like that kind of font. Let's do this. So I cubed. Oh, I should add I in here. Hold on. Let's add I in here. I equals the square root of -1. There. Okay. So I equals the square root of -1. I squared equals -1. So then to find I cubed, you're just going to multiply by another I. So I squared equals -1. To find I cubed, we have to multiply by another I. So we'll multiply it by, let's just multiply by I. All right, so times I. This is kind of annoying. This is why I do these things on the whiteboard. Times I. Okay. So you have -1 times I, which is going to be what? What's -1 times I? Don't overthink it. Think of I as a variable. Yeah. Oh, equals -I. Ugh. Really don't like that font. So I cubed is -I. Okay, so to do the problem, we have to find I squared, which we know is -1. We now know that I cubed is -I. One second, sorry. Wait. Okay, sorry. Text from my mom. I guess I could have paused you, but I didn't. So I to the fourth equals so I to the fourth, I like to think of that as I squared times there we go, times times I, we got this, times I squared, right? I squared times I squared is the same thing as I to the fourth. You would add your exponents together. Okay, so then we know I squared, it's -1. So you get -1 times -1, which equals 1. Hooray! So we know i's, okay, we didn't need to, for this problem, we only need to know I squared. I squared is -1. I cubed, oh, well, okay, is -I. And then I to the fourth, make it a different color, is 1. There. Now that you know all of those things, you can multiply them together to do the problem. So I squared times I cubed times I to the fourth. So I squared is -1. Actually, let's do it as an equation. Make it look all official. So -1 times I cubed, which is -I, times I to the fourth, which is 1. Multiply all those together. -1 times -I. Your negatives cancel each other out. So that's just I times 1 is I. So your answer is I. Whew. So this is I. There is a pattern, which we will talk about tomorrow. I don't want to do it during the homework help video because most of you don't watch these. Anyways, so number 20. I don't want to do number 20, but I will do a similar one to number 20. What if you can see the whiteboard? Can you see that well enough that you can that I could do it on the whiteboard? I think so. I can look that up. So I'm going to do, instead of that, let's do, I think you can see that. Okay, the square root of -9 cubed. There are a couple different ways you can do it, and you'll get the same answer. Here, I'll move you up and closer. Let's see if that helps. There went my marker. I don't think I can make it bigger. No. Okay. Oh. One way you can do it is, okay, what is, ignore the 3, ignore the cubed for a second. What is the cubed root of -9? The cubed root of -9 is 3i. Right? Okay. And then that is cubed. So this is 3 cubed times I cubed. 3 cubed is 3 times 3 is 9 times 3 is 27. And then I cubed, we figured that out in number 19. So if you want, you can just look back at number 19. Here, I'll pull it back up. I cubed was negative I. So this is times negative I. And if you multiply those together, you get negative 27I. Okay, so that's one way to get to your answer. If you did not know what I cubed was, sorry, 1 second. Okay, if you didn't know what I cubed was, so let's pretend we don't. We'll go back to here. So we have 3 cubed times I cubed. Okay, 3 cubed we can all figure out. That's 27. I cubed, if you don't know that it's negative I, you can go, okay, well, I times I times I. We know that I squared equals negative 1. I need to write a little bigger. We know that I squared equals negative 1. So then you have, that becomes negative 1 times I, which is negative I. So you get to the same place. So then you would have 27 times negative I, which is negative 27. Negative 27I, sorry. So you get to the same place. Another way, if you like this way or the way before, leave. But another way. Do I want to show you? Yeah, okay. So it was the square root of negative 9 cubed. Okay, if you're going to get confused by seeing another way, stop watching. So this is I just wrote it out. Cube root, sorry. Square root of negative 9 times square root of negative 9 times square root of negative 9. All right, so these two together is the square root of 9 squared, which we can figure out. That would be 3i square root of negative 9 is 3i squared, which is negative 9. Oh, we weren't going to do that part. My bad. You don't have to do that. These cancel each other out. I was wondering why it was harder than I thought. So that's just negative 9 times the square root of negative 9. Okay, 9 times square root of negative 9. I think I can fit it. So that's negative 9 times, this becomes 3i. So then you can multiply those together and you get negative 27i. So you get the same thing. So, yeah. Whichever way you do, just be careful. Okay. There. Now you can decide which way you like and go back and watch the video on it. And then forget the other way. So now that you know that, you should be able to do number 20 because it's similar. Woo! And I think that's it. All right.